Hello. In this video, let's talk about the linear regression and also let's talk about the training and the testing loops. And also let's see how we can improve the accuracy. Right, let's go back to here. So I'm using the linear regression. So let's start everything from the scratch. From torch, import nn. So let it be weight is equal to zero point 0.7. If in case, if you're wondering why I'm taking weight is equal to 0.7, bias is equal to 0.0, please watch my previous videos. And x is equal to torch dot arrange start is equal to 0, end is equal to 1, step is equal to 0.02, y is equal to bias plus weight into x, right? Okay, fine. X of two values, y of two values. Let's see the length of x, let's see the length of y. So this is something that we already gone through in my earlier videos. And so let's start with the class. Let's let's code like a pro. Even before that, what we will do, we will do one more thing. Let's split the data. So basically for training purpose, let's split like training and testing data. So for training, let's have 80% of the data, and for the testing, let's have 20%. So I would like to split data is equal to length of x into 0.8. 80% of the data I would like to have for this one. So let's round up this value. So split data. So basically 50, there are like 50 records, right? 50 into 0.8 is equal to 40. So let's have the variables like x train comma y train is equal to x of split data, y of split data, and then x test, y test is equal to x of split data and the rest, and y of split data and the rest, right? So it's always ensure that you check the length of each and everything, like y extend y trend. Sometimes we may do mistakes and the length may not match, which will cause an error in the later stage. So it's better, let's always write this one. Okay, 40 40 10 10. This is so good. Let's look at the class. So here for the class, import torch, and from torch I would like to import a model called nn. So class linear regression, let it be version 1, nn dot module defines a function in it. So self super dot init, right? So self dot weight is equal to nn dot parameter. I'm assigning a random variable here, torch n one random variable. So basically what this does, torch dot rand n, now one, basically it generates one random weight, one random value. So, and that data type I would like to be torch dot float 32, and self dot bias I would like to have the parameter torch dot rand n 1 data type is equal to torch dot float 32, and we need a one more class to pass the input values. So self comma x torch dot, remember capital T here, torch dot tensor. This is basically, this means that we are expecting the output to be torch dot tensor, like a tensor output. Okay, so return y is equal to mx plus c, right? Return self dot bias plus self dot weight into x, right? So this is fine so far. So I'm going to send model 1 is equal to linear regression version 1. Let's see our model 1. This is fine, and let's visualize the data. So for whatever we have written, so we have our x data, right? So this is a linear regression one. So let's see, import matplot lib.pyplot as plot. So define plot predictions. So train data is equal to x train, train labels is equal to y train, y train, train. Okay, test data is equal to x test, test labels is equal to y test, and predictions as well, let it be like none. Plot dot scatter, train data, comma, train labels, color is equal to blue, label is equal to training data. So let's call this plot predictions here, and also let's mention like plot dot show here. So okay, spelling mistake, labls, okay, fine. Okay, so we have these are the testing data, training data. Let's look for the testing purpose. Test data, test labels, color is equal to green, and label is equal to testing data. Okay. Okay, so we don't have any predictions, but once we have the predictions, the value we would like to see where exactly the prediction values as well. So if predictions, right now I have assigned predictions as none because I don't have any predictions. If predictions is not none, okay. So plot dot scatter test data, predictions, color is equal to red, label is equal to predictions. Okay, and now which color is what representing? So let's have plot dot legend. Okay, so the blue is represent the training data, green represent the testing data, but I don't want this to be here. I would like to have this to be here. So location is equal to 1.020, 1.020. Okay, so this one is fine. And let's start our training loop. Training. I mean, let's do the loss and optimizers. Okay, so because we need to calculate the loss, and for that loss we have the functions. Loss is equal loss function I want is equal to nn dot l1 loss, and this is nothing but the mean absolute error MAE loss, and optimizer is equal to torch dot optim params is equal to, we have our model 1, right, dot parameters, and learning rate this time I'm giving 0.01. Okay, this is parameters model 1. So what is the one? It's a model 1, right? So let's see, print model 1 dot state dict. Okay, we have the values here. Optimize the toss dot optim. Okay, so we have to mention the optimize the name as well. Okay, this is fine. Let's do the training loop. Okay, so toss dot manual seed 42 epochs. I would like to have this time like 200, and for epoch in range of epochs. Okay, so model 1 dot train, and then so let's calculate train predictions is equal to model 1 of x train, right, and so train loss is equal to loss function of, so the predictions is the train predictions we predicted this one, and the actual values are y train, right. So let's do the optimizer dot zero grad. So the good thing about the machine learning is that the code is same like every time. So basically, once you learn the code, you can repeat the code again and again. Loss dot backward and optimizer dot step, and model one dot evaluation, and let's, so the training loop and the testing loop basically, so instead of writing the inference, the testing predictions in the other cell, we let's do it in the same loop with torch dot inference mode. So test spreads is equal to model of 1, so let it be x test. So test loss is equal to loss function of this test values comma y test, the original values. So I, because we are looping for 200 times, let's have the output whenever it loops for at least for 10 times. If epoch modulus by 10 is equal to 0, so print f epoch epoch train loss, train loss, test loss, test loss. Let's do. Let me. Okay, the mistake I did here. So here I have mentioned a train loss, right? So it should be train loss here. Okay, let's run this one. Nice. So it started with 1.606, and it the train loss, it is like very less. You can see it over here. Let's see our plot dot predictions. No, let's predict the values with torch dot inference mode. Y preds is equal to model 1, which we train, of x test, and now plot predictions is equal to y preds. See here, see, I mean, the random values which are exactly sitting on top of the green values, which means that our loss is like very less, and we have achieved this one. And let's see how the loss curves decreased. So look at the loss curves. So I'm writing that same testing loop here, and then this time we will have a couple of arrays as well. So for example, torch dot manual seed 42 and epochs is equal to 200. So I mean for epoch in range of epochs, okay, model 1 dot train, this one, and then train parades is equal to model 1 of x train, train loss is equal to loss function of, and the prediction values is the train parades come actual values is the y train, which is good. And now optimizer dot zero grad, and it is like train loss dot backward, and optimizer dot step. So here model 1 dot evaluation, and with torch dot inference mode. So test predictions is equal to model 1 of x test, test loss is equal to loss function of test spreads y test. So basically now what we can do here, let's also have this one. If epoch, let's print the output here. Epoch, I mean, of course this is optional, you can directly print the output as well. So print f epochs epoch, so train loss. So this is something which we have seen already in the previous cell, right? So what I'm going to do, test loss, right? This is the same one. If you see, this is the same one, train loss. Okay, so now I would like to have these values. So basically what I'm going to do, I'm going to like epochs count, I'm going to take three arrays, train loss count, test loss count, right? So basically what I'm going to do here, for every 10 cells I would like to capture that value. So epochs count an array dot append of epoch, the value, and then train loss count dot append train loss, test loss count dot append test loss, right? So I have created the arrays here, the same output, nothing has changed. Now let's have a look at the curves, how it looks like. Okay, even before that, let's do with torch dot. So now we have created three arrays, which are these three, right? I'm copying this one. Okay, here. So this is fine. So this train loss count, I would like to see what is the type of this one. So print train loss count. Sorry. So print type of train loss count. So this is a class list, and let's see what exactly it is. The zero one. Oh, it is a torch dot tensor. Okay, fine. And this test loss count. Let's see. Print type of this of zero. So this is a torch dot tensor. Okay, both are fine. Let's do this one. In let's import mat. Let's draw train and test loss curves. Hmm. So we are at the end of, we almost at the end. So import matplot lib.py plot as plot, import numpy as mp because we need mpy as well. So of course we already have imported the torch, of case torch. So plot dot plot, so epoch count which created the new array, and then the train loss count. Okay, label is equal to train loss. So plot dot show. Let's see. Epoch count is not defined. What is this one? Epochs count. Okay, I'm so sorry for the spelling mistake here. So can't call numpy on the tensor. Okay, so this is an numpy. It can't call. So let's do this one. Torch dot tensor. Convert this to a numpy, and then convert this an array. Oh my god, so many typos. Okay, the loss curve for the training data, it is like this. So what we can do, plot dot legend location is equal to 1.02 comma 0. So this is the training loss. It is looking like this. Let's have a look at the test loss. Plot dot plot epochs count. So test loss count, or we can say like value. We could have named it like nicely. Label is equal to test loss. Let's see this one. So you can see the training loss, it is like this, and the test loss, it is like this. So basically, when we have increased the number of epochs, um, the value has been reduced, and also for the with the good learning rate. And so we can all so we can also mention like plot dot title training and test loss curves, plot dot x label epochs, plot dot y label loss. I'm just wondering why our train loss is like static here. But that's all about this video. So this is how we improve the accuracy and reduce the loss. Thank you for watching this video. In my next video, I'm going to cover about logistic regressions and other. I'm sorry. In my other next video, I'm going to explain how to save the models. Thank you.